Lesson 1.4, Task 1, Transformations of Absolute Value in Quadratic Functions. All right, it says analyze absolute value in quadratic parent functions. You can graph different types of functions using transformations of parent functions, which are the most basic form of each type of function. Recall that the absolute value of a number is its distance from zero on the number line. The parent absolute value function is f of x equals the absolute value of x. All right, this can be written as a piecewise function where f of x equals x if x is greater than or equal to 0, and x is equal to negative x if x is less than 0. And if you look at the graph, this is when x is greater than 0. You can see it's positive x, and you can see the slope is negative here. So it's negative x for all x less than 0. So together those two functions make up the absolute value function. Recall that this is an example of a piecewise function. A quadratic function is a function defined by a quadratic expression of the form ax squared plus bx plus c, where a is not 0. So therefore, a quadratic function must have an x squared term. If it has an x squared, something to the second power, that means it's quadratic, and has a parent function of g of x equals x squared. The graph of a quadratic function is a curve called a parabola. You can see that here. The highest or lowest point on the graph of an absolute value function or a quadratic function is called the vertex. All right, so here the vertex would be 0, 0, and here it would be 0, 0 as well. The graphs of f of x equals x, or f of x equals absolute value of x, and g of x equals x squared are shown. All right, which statement best compares the domain and range of f and g? All right, so your domain is your x's, so what happens going left and right? So going left, it continues forever. Going right, it continues forever. On this one, it does the same thing. They are going up. Both graphs are going up, but they're also going left and right forever. So the domain is going to be all real numbers. All right, so it says the domain of the two functions are the same. And it says 0 to positive infinity, and the range is negative infinity to infinity. Okay, so that's not true. We just looked at the domain of these as all real numbers. If we go ahead and look at the range as well, the range is your vertical axis or your y values. So this is going to be all positive numbers. Everything 0 and greater. This one will be 0 and greater as well. So domain, all real numbers, range, y greater than or equal to 0. So let's see what the second one says. The domains of the two functions are the same, negative to positive infinity. Okay, that part's true. The ranges of the two functions are 0 to infinity. Remember, the bracket means it's included, and since these come down and touch and go back up, and it's a solid, consistent line, those would be included. All right, it says determine which features are the same for both graphs. All right, the vertex are the same. We already said they're 0, 0. All right, intervals where they increase. Okay, so they both increase on the same side, and they both decrease on the same side. So they both increase greater than 0. So they are the same where they increase. They are also the same where they decrease. The end behavior as x decreases without bound. So as x goes to the left, both graphs go up, so those are the same as well. And the end behavior as x goes without bound. So as x goes to the right, it goes without bound. So as x goes to the right, both functions go up. So again, they are the same. So they have a lot of the same key characteristics. All right, describe the symmetry of both of the graphs. Are the functions even, odd, or neither? All right, so it's even if it's going to be a reflection, and these across the y-axis, and both of those are even functions. All right, how do the end behavior of the parent absolute value function and the parent quadratic function compare to that of linear functions? All right, so remember a linear function is just a line, so it goes down on one side and up on the other side. Both of these go up, so one's a V-shape and one's a quadratic, a curve, or a U-shaped graph, but both of the end behavior goes up or both go down. Where a linear equation, a line, if it's got a positive slope, then the left side's going down and the right side's going up. If it's got a negative slope, then the left side is high up and the right side is down. Okay? And if you want to read the math explanation, there it is. All right, so find the rate of change of the parent absolute value function and the parent quadratic function for the given intervals. All right, so the rate of change, remember, y minus y over x minus x. So between 0 and 1, the parent absolute value function is going to be 1. And because these are lines, these are going to be the same all the way up. Now the quadratic is going to be a little bit different. So from 0 to 1, it's going to be a rate of change of 1. Even though it's curved, you can see it's over 1, up 1. So it's still going to have that rate of change. So that's going to be 1. But when it goes to the next interval at 2, that point is 4. So your y value is 4. So if you use 0, 0, and 2, 4, we'll get a different rate of change. So let's go ahead and work that out. So 4 minus 0 over 2 minus 0, 4 divided by 2 is 2. But let's see what the question asks us. I'm not sure if that's what the question asks. Okay, it says from 1 to 2. So from 0 to 1, the quadratic was still 1. But let's see what it is from 1 to 2. All right, so from 1, so here it's going to be 1, 1. And then we're going to go 2, 4. So our rate of change is going to be 4 minus 1 over 2 minus 1. So 4 minus 1 is 3, 2 minus 1 is 1, 3 over 1 is just 3. So the rate of change for this one is 3. If you need to review rate of change, that's in one of the previous lessons. You can go back and do that. All right, now 2 and 3. Okay. All right, so we can't see what it's going to be at 3, but you can plug in the x and find out. So what's 3 squared? 3 squared is 9. So that would be a 0.39. And the previous point, I believe it says from 2 to 3. We know that's 2, 4 is that point. So it's going to be 9 minus 4 over 3 minus 2. 9 minus 4 is 5 over 1. So this one would be 5. All right, so the rate of change is going to stay consistent with the parent absolute value function because it's a line. But where the quadratic is a curve, it's going to get steeper the further it goes. All right, describe how the rate of change between consecutive non-negative integers for the two functions contrast. All right, so we just talked about that, the rate of change. Because it's a line, even though it's two lines put together, this is still a line and this is still a line. So it's going to have a constant rate of change. This is a curve, so it's not a constant rate of change. I believe that was the last question. It is. So if you want to read that, please pause the video and do so. And if you have questions, please let me know.